So following the process that we've been talking about here, let's do a modeling activity that's going to lead into formal requirement specifications. So this modeling activity needs some domain. Now, your project is going to be something you come up with, whatever you want to do. You probably came up with it already at this point in your mind, but you might consider, if you're not sure about what project you do, something you know enough based off of going through an activity like this. So in order to understand the domain, typically we have to have some way to learn about it. That's one of the secret things about being an IT worker, being a software developer, is we have to not only be really good at developing and learning software, we also have to be really good at learning everybody else's business. If you want to write insurance company software, you have to understand the insurance business. If you want to write banking software, you have to understand the banking business. If you want to write GPS receivers, you have to understand how GPS works and the physics that goes behind that, at least to some degree. And so we have to be great at going in and understanding the domain. And so we need to be able to go in and look at documents and understand what was written. We need to be able to sometimes interview people and figure out more of what we need and what we want from them. There's actually a whole role that's defined on projects that often does just this, just figures out what is it you really want, analyzes information. And so the way we're going to do this is we're going to use it and assume we have documents. We're going to pick a scope then from the documents and solve some part of the problem. So again, if you were to say, I'm going to solve banking, I can't go in and solve everything that has to do with the bank. I can't do mortgage and credit card and auto loans and everything else all at once. I'm going to pick some scope. I'm just going to worry about checking accounts for now. We'll come back to savings account when we get that done. Let me just worry about this one thing for now. And that's important here in our application, to pick a scope that we can be detailed enough to capture each phase and have it be useful, but not so detailed that it's going to kill us in the amount of time we're going to spend here. You should really, have something that is an appropriate amount of time to spend each week as we go through this class. So establishing the context for that scope is really important. It helps us see what needs to be included and what can be left out as we go. So in order to do this modeling activity, I've come up with an imaginary project. I'm calling it my home awareness system. It's kind of like a security system, but much, much smarter than that. So in order to do this, I want to do what can I do better around my house? What can I measure about my house? How can I respond to those conditions better? My house already has some sensors in it. It has a HVAC system with a little thermometer on the wall and tells me, is it hot or cold? But sometimes it's not a matter of being too hot, it's a matter of being too humid in here, or maybe not humid enough. I have other sensors around the house that might determine if the light should be on, a motion sensor, whether I should turn the light on or off. Or sometimes there's a sensor that says, hey, maybe the light should be on but dimmed. They have little ones around the house for night lights, for instance. They turn off during the day, they're on during the night. So how can I network all those things and have them do intelligent, cool behavior? That's fundamentally what we're going to try and do here. So this is a more detailed write-up. Now what I want you to do right now is pause this video and read this. And I'm going to continue on in just a second, assuming you've read it. So pause it and read it. Okay, so now if you're continuing on, I'm assuming you've paused, you've come back. If you haven't, pause it real quick. But you've read this. So there's a lot of information even in this little write-up. It's a lot of good information, and typically a write-up would have many, many more pages involved than just this. And so what do we need to model out of all this? Well, the key is we want to pick out important words. Sentences, especially in English, are full of lots of fluff. There's adjective and adverbs and things, worse, there's synonyms and antonyms that don't really add much good context inside of there. So we need to start with the words that are most important. So, for instance, let's capture the nouns. It's a couple cases noun phrases here because system's a bit vague. But we have a home security system and window and door alarms. So window alarms, door alarms, so alarms in general. Smoke and CO2 alarms, different types of alarms that are inside of there. But we can wipe out a bunch of that stuff and we get the nouns of what is the key players in our system. What are the key data points that we might need to capture, the information inside of our system. And so the nouns gives us the objects, the verbs start to point at actions we have here. So if we can limit our write-up to that sort of thing, we can figure out which nouns are really talking about the same thing. So when we say smoke alarm and CO2 alarm and stuff like that, are they just different types of alarms? Are they truly distinct objects? Or we'll get to that more in our modeling as we go, but then also which ones are valuable. There's going to be certain things that we can throw out. There's just, there's some random description. So from that longer write-up, and again, at any point you can pause and look over this detail in this list in more detail. But there's all these objects out there. So we have a temperature that we want to keep track of, humidity, smoke level, CO2. And then we have different actions we can pull up. So safety alarms. So if something goes off, or maybe it texts me or whatnot. We can adjust the living environment. We can turn stuff on and off. So again, like let's say I want to make a little greenhouse in one room and have a perfect little combination of temperature plus humidity. Well, if it gets too cold or too humid or not humid enough, it can text me and let me know, by the way, this room's in trouble. Something might be going on, or just a burglar alarm or a fire alarm or any of these sorts of things that could be going on. So even within this little simple write-up, we have a ton of possible objects. We have more than we can handle right now for this class or even for a big project. We have to start within some context like we talked about that helps us limit it. So we need to pick a problem to solve. So we thought we did that before when we picked one aspect. We want to narrow it down even further. What is one flow that I can focus on? What is one thing I can wrap my mind around? Or there's a couple different things I can wrap my mind around. So a couple problems I can see from this is one of them is just simply knowing what the status of a room is. So if we bring the sensors and some monitors into play, we can say, hey, is this room hot? Is this room cold? Is this room wet? Is this room being broken into? Is this room light? Is this room dark? We need some combination of querying the hardware pieces and rules on the software side that's going to determine some state or some action or some warning that's going to happen. Another problem separate from that would be controlling that. Changing that. Oh, the room's too hot, turn the temperature down. Room's too humid, oh, turn the dehumidifier on. Or turn the humidifier off, depending on how the room's set up. At this point then, we have some problems to solve, and we can go through and start picking classes in the object-oriented sense. Hopefully you have a feel for what object orientation is. I can't teach all of it right here, but I can pick classes and objects. I got to figure out, is the zookeeper an employee or a special type of person compared to the concession stand worker? They could both be employees. Zookeeper, concession stand workers could both be instances of the employee class, or they could be classes of their own. Maybe there's different behaviors I want out of them. It depends on the context of the system I'm building. If I'm building the HR system, it doesn't matter what your job is. I'm going to pay you. If I'm building the system by which I manage animals, then it's really important difference. So from those nouns and verbs that apply to solving the problem that we just defined at, I can pick the objects and the attributes and the methods. So what are the classes, the objects that realize that work, and then what is the data that I need to know about that object? What are the methods of what it does? So we're going to see this popping up here in a second. We're going to see an example from our context, but if we think back to the write-up that you read, what are the things that popped out? Well, a sensor's out there. That's a class that we're going to have inside there. Well, we don't know about a sensor. A sensor has an ID. A sensor has a location. A sensor has some data that's going to return to us. What methods are going to be there? Well, a sensor can be, reset. A sensor you can query the sensor for data. That's the type of thing that we're going to capture as we go along. So here is two of those, as I was just talking about, a sensor and a monitor. As we saw, the sensor has a model number, unique ID, password, location code, power mode, battery level. Those are things we picked up in the write-up or otherwise. Maybe we asked a question, hey, what's the sensor look like? Do you have a document from the manufacturer that tells us what we can do? I mean, it's a piece of hardware. It has some limitations of what it does. I'm not entirely making it up, right? The monitor is a bit more virtual. So in this case, one of the things came from the real world. Objects often come from things I can put my hands on. Sometimes they're virtual. So if I go to a store, I can see the product. I can see the shaving cream. I can see the drink that the soda you're gonna do, the plants that are out there, the computer hardware that I'm gonna sell. What I can't see is the shopping cart in an online store, but that was a physical thing. So sometimes I take physical things and move them into the virtual world. what I can't see is a transaction. I can't see a line item. Well, those things kind of show up on receipts at some point, but they're virtual concepts. In this case, the monitor is that virtual concept. The monitor has this list of sensors. I'm going to look at the humidity level and the temperature, and I'm going to be monitoring for optimal plant growth conditions inside of there. So there's different things that can come up from that. The next thing I want to do then, after I capture the data, is capture the behaviors. What are the things the sensors do? At this point, at the requirements level, I can talk about them in long text. I'm not trying to make true methods out of them, but the sensors, they're querying them for data. I can reset a sensor. The monitors are looking for basically something to do inside of there, and I have some sort of schedule that the monitor runs on. And so all this culminates in UML. The same stuff we do in design, I can pull it up as far as the analysis level. I can see all of this words, all that textiness that was out there in a quick picture. So I can see in this piece that I want to monitor a room, I have a monitor which looks at a bunch of sensors. I can see the data that's part of each of them, the behaviors that are part of each of them. And I'm starting to show other things like the results. When I do a monitor, I see the results that come back. Is there a problem? Is there an alert? What time is the alert that came up? And so this initial modeling activity gives us a more robust way of capturing information and looking for things that are missing. Nobody thought to say, what are the results of a monitor per se? But when I wrote a method down there, monitor, well, what does it return? It needs to return something. Well, hey, what should this monitor return? I asked the question. We should have some results. What do you want to know in the results? Well, we want to know if there's a problem. And then what time did the problem happen? What types of alerts is it seeing? Oh, it's too humid. Oh, it's too hot. Oh, it's too whatever. And so now, through this modeling activity, we've refined our understanding of the system. And our next step along the way is to be able to start writing this stuff down. There's a couple different ways we can do that. So my recommendation to you is to watch both ways and then choose which one you're going to go through and take, and go from there for your project.